Hi everyone, welcome back to our Mist AI-driven SD-WAN configuration guides series. My name is Shai Donovich. I'm a solution architect here at Juniper on the Mist AI-driven enterprise team. And this is going to be section 7 of part 2, the configuration guides. We'll take a look at how we can configure source NAT from spokes to hub via the overlay in a hub and spoke topology. This is useful when we have overlapping IPs in each and every site, and then we want to communicate with our hubs. So with that, let's get going. Okay, so just a quick recap. This is our lab topology. We have 3 sites, site 1, 2, 3, and 1 hub, hub A. We have different LAN segments here that is basically emulating different use cases. As you can see here on the right hand side, this is what I've already covered in part 1, which is the overview part. And we already covered LAN 0 in our previous sections of part 2. So I highly encourage you to go back and watch section 1 through 6 in part 2. And in this section, as I mentioned, we're going to take a look at LAN 1, which is our overlapping IPs use case. So if you consider then LAN 1 to be overlapping IP, we'll show you how to configure source NAT on each and every site and also accept traffic on the hub. So just again, to baseline ourselves, let's say site 1, I have 10.168.1.1. This is a host on a 0/24 network, and it would want to communicate with the hub A LAN 1 host, and we're gonna source NAT when it leaves the spoke using the overlay. We're gonna source NAT this to 192.168.1.1. 1 stands for site 1. Similarly, from site 2 and 3, traffic will be NATed because it's an overlapping IPs, and each and every site is the same segment. LAN 1 is same segment, and 168.1 /.0/24, and hence we need to source NAT it to a different IP, so the return traffic from hub towards the site would know how to get back to the respective site. So 192.168.1.2 is going to be NATed from traffic that is coming from site 2 and site 3, and so on. And for that, as you will see in the next few slides, we're going to take a look at how we use site variables and use them on networks. Again, I covered this already in previous sections when we discussed LAN 0 use case. But again, this is a very powerful way to use a single template that is associated with multiple sites on Mist. So we're gonna do this here in LAN 1 as well. So now let's take a look at our lab topology. Here's our VSRX spoke and hub. I just isolated one site, site 1, just for me, just so it will be easier for me to explain what parameters and configuration we need to use on the LAN 1 network. And then, as we already discussed, it would be replicated and used on all sites, all spokes. So in this case, just to make it more realistic, LAN 1, we would probably have multiple hosts on LAN 1, right? So again, LAN 1 on the spoke, which is the 10.168.1.0/24 segment, we would want it to communicate or to send traffic towards hub A LAN 1, which is 192.168.100.1. This is the host here. Assume, let's say, we have an HTTPS server, web server on LAN 1 deployed in the hub, and each host on the spoke would want to access this server. The communication is only going to be initiated from the spoke side to the hub, and not vice versa. So again, just to make it realistic, I've added two more segments here. Sorry, two more hosts here on the same LAN 1 segment. So we have H1, host 1, H2, and 254 is actually the interface here on the VSRX 10.168.1.254. And then each one of the hosts is going to be .1, .2, .x, right? I mean, so again, realistically, we have the segment, but we're not going to have probably one host deployed in each side, but multiples. And so then if we take a look on what's going to happen here, each traffic that is generated from each and every host will be source NATed, in this case to using one single IP. In my example here, I'm going to be using 192.168.1.1/32. And then so what I'm basically showing here that each and every host on LAN 1 is going to be source NATed to the same IP, going to the hub using the overlays. And so basically the network here again for site 1, LAN 1, the network is 10.168.1.0/24. And so we would need to advertise to the hub a network or an IP that the hub would need to know how to have the reverse traffic reach a specific spoke or the right spoke. So in this case, we're going to advertise on behalf of site 1, LAN 1. We're going to advertise this one single IP, which is this 192.168.1.1. Because that's going to be the IP that every host here, we're going to be source NATing to this IP and sending it to the hub. And obviously in site 2 and 3, it's going to be .2, but again, just looking at the example of one site to make it more clear. So we would need to configure on the network under Mist 3 different parameters for site 1. So first of all, we would actually need to configure the 10.168.1.0 segment or network, which is the actual IP that all these hosts of LAN 1 are going to be sitting on. And then we're going to configure source NAT pool. And in this case, again, I've chosen to use a /32 pool and 192.168.1, which is going to be our source NAT. And spoke 1, site 1, as we mentioned, will be advertising via IBGP through the overlay, because we have IBGP sessions running between spokes to hubs. So it's going to be advertising 192.168.1.1. And again, the reason is because the hub would know how to have the reverse traffic going to the right side. And if we look at the hub side is obviously very simple. We have one network, which is 192.168.100.0. And we have one host here because I have installed HTTPS server on this host, so we will be able to get RDP session on each one of these hosts and see that the traffic is actually working and flowing correctly. And so when this spoke 1 will send traffic to hub A, it would actually send traffic after it leaves the spoke. It's going to be, as we mentioned, 192.168.1.1 going to 192.168.100.1. And so because we're advertising, the reverse traffic would know how to get back to spoke 1. Very similarly on spoke 2, just so we have it written when we configure the networks, the same network will exist in site 2, spoke 2, because as we said, that use case is actually an overlapping IPs. And then the source NAT pool is going to be .2 and not .1. And then also we're going to advertise .2. So basically, again, .2 is going to be going to the hub .100 network, .101, which is the host on the hub, and it would know how to get back because this is what we're going to advertise. And as you probably figure out, it's going to be the same exact on site 3. However, the IP is going to be different. And so for that, there will be deployed a security policy. Mist will deploy a security policy, part of the application policy, a security policy on this VSRX, allowing .x, whatever, .1, .2 on each side is going to be different, allowing traffic going to .0 after it has been source NATed. And obviously on the hub, we'll have a security policy that should receive traffic. However, here is what we're going to do. On the hub, we're going to have one security policy that is going to be accepting traffic from a .0/24. The reason is because let's assume we have multiple sites. Each site is going to be .1, .2, .3, .4, and so on. Well, depends how many sites we have, but let's assume it's a /24, 256 sites. So we would want to have on the hub a policy that is accepting traffic coming from the overlay, which is the .0/24, from all sites going to this 192.168 network on the hub. So this is why I just pointing it out, because you'll see in the next slide we would need to use different variables on different sites in order to make it happen, because here again on the spoke side is going to be a /32, a specific IP, and on the hub side it will accept traffic from all spokes, and this is why I mentioned it's going to be a /24. Okay, so now let's look at how we configure the network and use the right site variables and use the variables in the networks in order for these IPs, as we outlined here, to be configured correctly. So again, based on the Mist intent model, we always communicate between a network to an application. In our case, again, the network is spokes LAN 1. And then our application is the hub LAN 1 network in this case, right? We covered applications in previous sections, whether it is a layer 7 applications or just a custom application, which in this case is just identified by a prefix. So, please go back and look at that segment in previous videos. So if I take a look at configuring or creating spokes LAN 1 network here, I need to configure then specify the network prefix, and in this case it's going to be the .0/24, and we would need to, as we mentioned, configure a source NAT pool, and since the last octet is identifying our site, we'll use a site variable, site_number, to signify the correct IP when this network is deployed on each site. And we also need to override the prefix to advertise towards the hub, and because we would not want to advertise the 10.168.1.0 network, the original network, because the hub doesn't actually see this network. I mean, everything is going to be source NATed to the source NAT pool. So we would need to override the advertisement. I'll show you in the next slide how we do it on Mist as well. But in this case, I wanted to override this with 192.168.1.site number, as we mentioned, and the prefix when it's going to be LAN 1 mask, and when this going to be resolving and configured under the spoke side, it will resolve and will result in configuring the advertised prefix to be a /32, as we mentioned in previous slides. And however, just know that on the hub, as we mentioned, Mist would need to allow this network, spokes LAN 1, on the hub. It would need to allow this network to communicate with the hub host, the .100. And in this case, we would want to make sure that this advertised prefix, or the 192.168 network, would actually be resolved to .0/24. So again, we're going to use site number, and the site number variable on the hub will resolve to 0. And the LAN 1 mask on the hub will resolve to a 24. So yeah, just want to kind of again, the point here is I wanted to make you aware that this network that we will create, when this network, the config is pushed to a spoke device, the network will be a /32 and based on the site number. But when this network would need to be allowed, meaning there's a security policy that would need to be configured on the hub, this network will resolve to .0/24 based on the different variables that we will have on the hub. And so here's our variables. So we will go ahead and configure in site 1 site number equals 1, which by the way we already have this variable because we used it on LAN 0 use cases, the previous sections. And LAN 1 mask, this is the additional new variable we have on site 1. It will resolve to 32. And based on these two variables, these are going to be the IPs that we will get when config is pushed to spoke 1, site 1. Similarly, on site 2, we already have 2, but the LAN 1 mask on site 2 is going to be again 32, and this is going to be the network according to what we have specified. And site 3 is going to be 3 and 32, and we'll get this network as well. And on the hub side, again, in order to make sure we'll have this network resolved correctly on the hub, we'll set the site number to 0 as we did already in the previous use case for LAN 0. And then LAN 1 mask variable on the hub side will resolve to 24. And in these two parameters, it would actually, these two variables, the network that will be configured in the security policy on the hub to accept traffic is actually going to be the 192.168.1.0/24 using these two variables. So next, let's see how we configure the networks and application under Mist to allow this traffic. So the first thing we need to do is to configure or to add the LAN 1 mask variable under each site. In this example, I'm showing site 1, which is going to have adding a /32 as described, and also hub A, we're going to have or add a /24. So let's switch to Mist UI, and I'll show you how to configure this one as well. Okay, so let's go ahead and navigate to our site settings under organization, site configuration, and we click on site 1. And if we scroll down, we can add another variable here for the LAN 1 mask. And that's going to be a /32. And since we have already cloned those sites, we would need to go ahead and do that for site 2 and site 3. But again, if you create first your template, the way to create it, you first create a template and you apply it to site 1, and then you're gonna go and clone these sites, right? But since we made these series of videos step by step, I would need to go ahead and quickly add the same variable LAN 1 underscore mask to all sites, site 1, site 2, and site 3. Click on save. Okay, and also we would need to go ahead and configure on hub A site. We'll add the same variable, but as a reminder, it would need to resolve to a /24. Okay, we added our variables, and next we would need to go ahead and configure our networks. Okay, so next we're gonna create this spokes LAN 1 network that is gonna apply to all spokes, and the configuration that we need to provide is gonna be the following. The name is gonna be LAN 1, and the IP address of that network is gonna be .010.168.1.0/24. And we would need to configure, as discussed, the source NAT pool prefix, which we want to source NAT it to 192.168.1 the site number. This is why we're using the variable, and we'll click on advertise to overlay, meaning this network we would want to advertise to hub what is the IP. However, we're gonna override the prefix to advertise. Instead of advertising the original network, which is the 10.168.1.0, we would actually advertise the 192.168.1 site number and /32, because that's the LAN 1 mask that is going to be resolving on each site. And if we look at the Mist UI, that's how the screen looks like. Name, IP, here's where I clicked on advertise, override prefix to advertise. And so when this is going to be, again, as mentioned, applied to site 1 in this example, this is going to be the IP that we'll be resolving. And when this network will apply it on hub A for the security policy, it's actually going to be resolving to the .0/24 as discussed in previous slide. So let's quickly jump to Mist UI and configure this network. So we're gonna go ahead and navigate to networks, and we can add a new network. And the name is gonna be spokes LAN 1 168.1.0, and it's going to be a /24 segment in each and every site. And here's where we're going to configure the source NAT pool. We would want to source NAT this network, which is going to be 192.168.1. The site number, and it's going to be a /32. And we would want to advertise this via overlay. However, we would want to override the prefix. Instead of this 10.168.0, you can click on override prefix to advertise, and you can then go ahead and advertise this other, the same 192.168.1.1 in this case, but the prefix length is going to be LAN 1 mask. Okay, so we can go ahead and click on add, and here we can see the new network has been added, spokes LAN 1, and it shows that we have a source NAT pool, and this is again related to source NAT pool towards the overlay. In the next sections, we'll discuss static NAT and also destination NAT. But for now, we have this only, this segment is only doing source NAT towards the hub. We also need to add hub A LAN 1 network and also application. But this is pretty simple on hub A LAN 1, the application itself, because we're going to be communicating from spokes towards this application, from network to application. So it's going to be only the prefix 192.168.100.0, and we're going to also add a network that we would need to apply on the hub, added to the hub profile. And again, the network is a pretty simple network configuration, no nothing, just 192.168.100.0 and /24. And we want to advertise this via overlay, meaning the hub advertises this network to the spoke. So obviously the spoke would know how to reach this network when sending traffic towards this hub A LAN 1 application. So let's switch quickly to Mist UI, and we'll configure this one network, the hub LAN 1, and also the application. Okay, so next we're gonna go ahead and add our LAN 1 network to the spokes template, 1H template, and also to the hub profile. So again, we're gonna be adding a new LAN segment to this VSRX site 1, which is gonna be the LAN 1 using the network we have configured, and also on the hub we're gonna be adding LAN 1 as an additional host connected to the VSRX. So again, the entire, all communication is between network to and applications, and we have configured this application, Hub A LAN 1, and the original spokes LAN 1 network is this 192.168.1.0 before it's being source NATed. So if we take a look then on the VSRX on the spoke side, it's going to be going to hub A LAN 1, and we're going to add G003, which is the next free interface we have. We're going to apply this network, and we're going to give it a DHCP server as well. Just as an example, 10 hosts here, 254 is going to be the interface here. And very similarly on the hub, we're gonna add the network we have created, hub A LAN 1. We're gonna add it to the hub profile, hub A hub profile, and we're gonna use a DHCP server as well, although not necessarily, but we can use it as well. Okay, so now once we added the LAN 1 interface to each and every device, let's quickly take a look at our devices to make sure we have the additional interface configuration pushed already. Show configuration interfaces. We can see G001, here's LAN 0, and we can see that we have a new interface G003. LAN 1, which is 10.168.1.254 as we have configured, and if we look at site 2, we would expect to see the same IP. As we mentioned, this is going to be an overlapping segment. Each and every site has the same IP, 10.168.1.254. This is G003 on site 2, and obviously we have the same on site 3. Here's our site 3. And if we look at the hub A routing table, well, first off, let's look and see if we have an additional interfaces added here as well. And here's G004, LAN 1, 192.168.100.254. And if we look at the routing table, VPN overlay, we can see that we have these three IPs, the ones that we configured as override prefix to advertise, 192.168.1.1, and then .1.2 coming from overlay pointing towards the ST tunnels, the IPsec tunnels going to each and every spoke. And here's .1.3. So we can see we actually have these three IPs, which correlates to the source NAT pool and the advertised prefix from each and every spoke. So we should be good to go now to create our application policy and then see if we have traffic flowing between spoke and hub. Okay, so now once we have created our networks and attached them to the devices, G003 on the spoke and 4 on the hub, we can go ahead and create an application policy and then a steering profile as we have done previously for LAN 0. If you haven't watched those segments, please go back and watch the segments in part 2 where I show how to do this. But in general, we would add an application policy that will allow spokes LAN 1 network going to an application hub A, which we have created. And obviously the same will be applied on the hub. And so in order to do that, we would also need to create on the 1H templates for the spoke a traffic steering profile. In this case, we already have created 2 VPN steering profile on the spokes template because we have used the same steering profile that was used for LAN 0 going to the hub. And on the hub side, we would need to create a new steering profile that accepting traffic from the overlay and steering it towards LAN 1 instead of LAN 0, which we have created previously. So that's going to be then profile name to LAN 1, and the path would be hub A LAN 1. And after we'll do that, we can go ahead and create an application policy in our central repository for the applications. We'll select the from network, which is the from, it's going to be LAN 1, and then we'll be able to select our application since we have already added hub A LAN 1 application, and the action would be allow. And then in each one of these spoke template and also the hub profile, we'll be able to import this one single policy that we have created, and then just to apply the correct steering profile. So on the spoke template, we will apply the steering profile saying to VPN. And on the hub, the steering profile would actually say to LAN 1 because it would accept traffic from the overlay going to LAN 1. So let's jump back to Mist UI and we'll configure this application policy and also then import the application policy into each one of the templates and create the additional steering profile on the hub. Okay, so now that we have added our application policy and configured the steering profile on the spokes 1H template and the hub profile, config has been pushed to the device. We can go ahead and check what's the config for the source NAT and the policy that has been applied on this device. So here we are on site 1, and if we look at the source NAT configuration, we can see that there's a new source NAT from zone spoke LAN 1 going to the overlay zone, and we're matching on any address, but we are applying a source NAT pool of 192.168.1.1/32 as we've configured. Again, just a reminder, this is actually a name that is resolving in the security address book to 192.168.1.1/32. And if we look at also the policy, we can see that source address, our 10.168.1.0/24 network, which is the LAN 1 network on the spoke, going to the hub LAN 1, which is 192.168.100.0. We're allowing this traffic to go to the hub. And if we also check on site 2, we can look at the source NAT. We can see that we have the same source NAT policy, but the IP, the pool is applied, which is .2. We can actually check the pool, maybe match on pool, and you can see that there is a configured pool 192.168. That's again the name, and the address is 192.168.1.2 because this is site 2. And then obviously this is applied on the source NAT. And if we look at our policy, so we can see that the policy is again the same exact policy as we have in site 1. Source address 10.168.1.0, same segment, going to the hub, and the application is the policy is allowed. Looking at site 3, we have, as expected, we can see that we have the source NAT pool configured to 192.168.1.3 as it's site 3. And the same, if we look at the policy, again, same segment. And if we look at the hub, just to make sure we have the correct policy, we can see that we are accepting traffic coming from the overlay zone 192.168.1.0, which is the whole /24 as we have expected and configured, allowing traffic towards this one host that we have on the .100.0 segment. So traffic is allowed. So we can go ahead and quickly check connectivity now. So here's site 1, LAN 1, host 1. This is the host that is connected to the site 1 spoke. And if we list our interface, we can see that the IP is 10.168.1.1. ENS3 as expected, and also if we look at our default route, we can see that the default route is pointing towards the 254 interface, which is our interface on the VSRX, and we can go ahead and ping our host on the hub 192.168.100.1, and we can see that we are pinging. And similarly, here is our site 2 LAN 1 host 1 is the one that is connected on site 2. If config ENS3, we can see that we have the same overlapping IP 10.168.1.1 on site 2 as well. And if we look at our route, we can see that default is again pointing to the VSRX, and we can go ahead and check connectivity and ping our 192.168.100.1. Again, this is the host on the hub side, and we can see that we can ping also from site 2, although it is an overlapping IP of that VM, we can ping the host as well. And the same if we can go to site 3, LAN 1, host 1, we can see that also the IP is the same, 10.168.1.1. And if we ping our host on the hub, we can see we can ping from Spoke as well. All right, so in this segment then we covered the LAN 1, which is the second use case we wanted to show using source NAT, going to overlay from spokes to hub. And again, this is useful if all spokes are communicating with the hub, if you have some workloads or resources, web servers, etc. But in this case, there's no communication from the hub to initiate towards each and every spoke. That is going to be covered in the next section, where we're going to look at destination NAT, meaning the hub would actually go towards the spokes. And also we have static NAT if we want to just NAT each and every IP on the spoke to the hub. So in the next video, we're going to take a look at LAN 2. That's our third use case where we're going to add another interface on the spoke and on the hub. It's going to have a different IP address just so we can identify this use case. And in this one, we'll show how to configure static NAT. And as you will see, each and every host on the spokes is going to be statically NATed to an IP going towards the hub, and so the hub can have communication back to the spoke as well. This is what is referred to as one-to-one NATing. So with that, see you in the next video, and thanks for watching.